the previous video, we see the KCL and the KVL. So today we are going to see some example how to solve the current by using KCL and KVL. As we are seeing this example, we see in the KCL, we already know that summation of current entering plus summation of current leaving equals 0 in a node. We're already in a node. So we are going to do this example. For this circuit, use KCL to find the branch current I1 to I4. I1 to I4. We want to determine I1. We want to determine I1, I2, I3, and I4. So let's see. We have to look at from this node. This current is entering. This current is entering. This current is leaving. So mean that I will have I1 plus I2 because both current are entering equal the current leaving. But I don't have the value of I1. I don't have the value of I2. So if I check this node again, this current is leaving in this node. This current is leaving in this node. This current is leaving in this node. Mean that I1, I2 plus 3 plus 7 equals 0. Because this one is leaving, this one is leaving, this one is leaving. If you take this one, you see this one. This one is entering, this one is entering, this one is leaving. So I will have 7 plus I4 plus I3, 7 plus I3 plus I3 equals 0. Plus I4 equal plus I3 equals 0. If I check this one in this node, I will have this one. This current is entering, this current is leaving, this current is leaving. So in this node, let's say for example this one node 1. That's node 1. I will have this current 2 is entering, this current is leaving, this current is leaving. So I will have 2 is the only current which is entering, here it's supposed to be equal. I can write like summation of current entering equals summation of current leaving here. So I will have 2 equal, because it's the only current who is entering in this node, 2 equal I4, because I4 is what is leaving, plus 4 plus 4 plus 4 plus 4, because 4 ampere is leaving also. In this case I will get I4 equal 2 minus 4 is going to be minus 2 ampere. That is the value of I4. Now we found minus. What does mean this minus? What does this minus mean? This minus mean the normally you saw the arrow of the current is I4 is coming from this direction, and we get negative, mean that normally this circuit the current will enter in this side, will enter. That's the meaning of this minus. So why I start from here? I just to make easy for me, because in this node I have only one unknown, I4. That's why I start from this side, because if I start from here I will have I2 and I have I1 as unknown, so it will make me some problem. That's why I start from here. Now if I come this node, let's say this one, node 2. At node 2 I will have this current is entering I4, this current is entering, this current is entering, is leaving, this current is entering, this current is entering, this current is leaving. Here enter, here enter, mean that I will have I4 plus 7 equal, this current is leaving, I3, so equal I3 is the only current it is leaving. So I will have I3 equal I4. What's the value of I4? The value of I4, it is minus 2 plus 7. So I4 is going to be equal 5. I3 is going to be equal 5 ampere. I3 is going to be equal 5 ampere. Mean that either I get positive, mean that this is the really direction of I3. Now I can come for this node 3. In this node I'll have this current is leaving, this current is leaving, this current is leaving. So I will have I2, there is no current is entering, plus 7 plus 3 equal 0. Why 0? Because there is no current is entering in this node 3. There is no current entering. We are at node 3. So in this case I will have I2 equal 7 plus 3 equal 10. If this 10 come in this side, is going to be minus 10 ampere. So if we will see I get negative, is not problem. That's the real answer. Why this negative? This negative show that the direction of I2 is not the correct direction. Mean that the really direction of I2 is this direction. That's why this minus. Because it is logic. In one node, all currents cannot live in. How can they live without one current will enter in? One current have to enter, and the other will leave. That's why this minus mean the current should be this one. But since he put the current this one, there's no problem. We will put this negative one. So when we come at node 4, this node 4, I will have this current is entering I2, so I will have I2 plus this current is entering I1 plus I1 plus I1 plus I1 is going to be equal. This current is leaving from this node, equal 2. Now I want to find I1, so I1 equal 2 minus, I will take this I2 to come in this side, minus I2. So finally I will get the value of I1 equal 2 minus the value of I2, which is minus 10, is going to be equal 12 ampere. Mean that the value of I1 is 12 ampere. Let's see. I have a value of I1, which is 12 ampere with entering. This 12 ampere will separate the 10, this 10. We already explained this negative means that the negative means that the direction supposed to be this direction. Is going to separate this 12 ampere. The 12 that's here, 10 will be in this direction, then 2 will be in this direction. This 10, 3 will come in this direction, the 7 come in this direction. This 7 we have I3, 5 is going to be in this direction, and I4, 2 will be in this direction. This 2 is entering, these 2 also entering, 2 and plus 2 is going to be 4. Mean that's we solve this example using KCL. The KCL in a node, the summation of the current entering in the node equal the summation of the current leaving in the node. There's no problem. Someone can start from here, but if we start from here, you'll have I1 plus I2 equal 2 because they are entering, but you don't have I1, you don't have I2. You keep that equation. You come here in this node, you found the you make the equation again. You come here, you make the equation here. You come here, you make the equation here. In this equation, you get I4. Here you will replace the value of I4, you replace the value of I3, and by the end you get all the currents that we are looking for. Next, we will see example using KVL. We already discussed KVL theorem, the previous video. I will suggest everyone to go in the previous video for better understanding before come in this video. Now we'll solve this example using KVL. We say KVL that in a loop, we discuss what is loop. Summation of the voltage is going to be equal to 0. Let's see in this example. Given this circuit, use KVL to find the voltage V1. I want to find V1. I want to find V2. I found V3 and found V4. Read carefully because it's not. We have to find not only the value of V1 and V4. We have to find the value V1, V2, V3, V4. So let's see. I have this loop. I have also this loop. I have also this loop. We discussed about loop yesterday, that it is a closed path in a circuit. We have this loop. So let's say, for example, this one, I have loop 1, I have 2, I have 3, I have 4 here. In loop 1, I will have, we say that will follow this arrow. We'll follow this arrow of our, this arrow when come in the first element. What is the sign? Negative, mean that -3. This arrow is going to be in the second element. What's the first sign? Plus V1. This arrow is going to be in the second element, minus V3 equal 0. So in this one, I will have V1 minus V3 equal this 3 minus 3 is going to be in this side, equal 3. You have the first equation. Now I come to loop 2. If we come to loop 2 here, this arrow is coming in this positive. We say that it will follow this arrow. We take the sign of the first sign that this arrow is coming in the element. This arrow is coming in this positive. I will have 4. 4 means that plus 4. This arrow is coming in this positive, plus V3. Here, this arrow, I continue the arrow, I come here. It's going to be plus V4 equal 0. Now I will have V3 plus V4 equal this plus 4 is coming in this side, is going to be minus 4. I have this question again. Now I come to loop 3. In loop 3, this arrow become this side. I will have minus V1 because the arrow come in this first sign, in this element, minus V1 minus V2 here. I will have plus 2 because this value will give me the value, it is 2. So I will have plus 2 equal 0. So I will have minus V1 plus V2. This is going to be minus 2 here. Since it's going to be minus 2, I have 0. This minus 2 is going to be here. Or if I take this minus V1 to come in this side, I will have V1. I come this one, this minus V2 to come in this side, I will have plus V2 is going to be equal to 2. Now I come in this loop 4. When you come in loop 4, I will have what? I will have this arrow will come in this side. I will have minus V4. Here is going to be plus 2. Here is going to be plus 5. Plus 5 equal 0. this arrows come in the beginning, this minus, that will come minus 4, v4 plus 2 plus 2 plus 5 equals 0. So by the end I will get v4 equal 2 plus 5 is going to be 7. This minus 4 come in this side is going to be v4, so I will have v4 equals 7 volt. Now I already found v4, so I have to find the others. I don't have v1, I don't have v2 here. Here I can calculate v3 here. I will have v3 equal minus 4 minus v4, so I will have minus 3 minus 4 minus 7 is going to be minus 11 volt. So v3 I calculate is minus 11, v3 equal minus 11 volt. Now if I come here again in this equation, I have v3, I calculate v1, I will get v1 is going to be equal 3 plus this minus v3 is going to be in this side, I will have plus v3. Now it's going to be 3 minus 11, you get the value of v1. Now I have the value of v1, I can come in this equation to get v2. I will have v2 equal 2 minus v1. The value of v1 I already get from here. I hope everyone already can understand in this explanation. If you form this equation, if you get v1 minus v3, don't worry, just to found all the equation in this all node. You see by the end we get v4, and we keep replacing the equation. We keep replacing the equation to get the other voltage. Thank you for watching.